All right, we're taking a look at Chem 30 here, and this is another pH slash sort of Ka acid-base type calculation question. So this is a sample of a student's work here, and question number 14 says, what's the hydroxide ion concentration for this 0.0044 molar HCl? And hydroxide, of course, is OH minus. Okay, so we want to start off with the equation, and this is correct. HCl plus H2O is in equilibrium with H3O plus Cl, and of course you want to include the charge there, so we're missing a sign there. But this is generally the proper equation. Okay, so now I think this is where we get off. We maybe get off just a little bit off track here after this. So let's take a look at finding. What we can find is the hydronium ion concentration. We can find that pretty easily. Okay, so let's take a look at that. So if we know that this is 0.0044 molar for HCl, and HCl is a very strong acid, so it actually fully dissociates, right? It completely dissociates. So this is a 1-to-1 ratio. So what we have is we have hydronium ion, H3O plus, is 0.0044 molar. Okay, according to this, because HCl is a strong acid, it completely dissociates 1-to-1 ratio. So that's not what we're looking for, though. We're looking for the hydroxide ion concentration. So if in a solution we know what the hydronium ion concentration is, because we know what the ionization constant of water is, and that's 1 times 10 to the negative 14 molar, taken to the negative 14, we can figure out what H3O plus is, right? So the product, this is actually the H3O plus concentration times the OH minus concentration. So we can do just some simple calculations here. And so 1 times 10 to the negative 14 divided by this H3O plus 0.0044 should give us the hydroxide ion concentration for number 14. So if we get out our calculator and let's do that here. So 1, use your exponential there, or your scientific notation, negative 14 divided by 0.0044, and we get 2.27 times 10 to the negative 12. 27 times 10 to the negative 12. That's going to be molar, and that's going to be our concentration of OH minus. So that is the answer for 14 there. Okay, so unfortunately we're a little bit off track here with this work here, but this is how you would do 14. 15 is asking for the pH and the pOH. And of course that becomes pretty easy when you know that you have the hydronium ion concentration and the hydroxide ion concentration. You simply use the negative logarithm, and for pH you use the H3O plus concentration. And for the pOH, we're going to use the negative log of hydroxide ion concentration. So if we input our concentrations here, this is correct here. So the pH is 2.36 for pH, and the pOH is, you put in the OH concentration into the negative log, and you get 11.64. The other thing you could have done, of course, once you found pH, if you did that first, you could do 14 minus 2.36, and that also gives you your pOH. Okay, so and you can round this to 1 decimal place is totally fine as well. Okay, so those are your answers for number 14 and 15 there on your assignment, and yeah, hope that helps.